Let us look at an example program that implements Phong shading. This is the vertex shader for the Phong shading model. We get the vertex positions and the vertex normals as usual from the application program as in variables. But the difference is here where we define three out variables that are the normal vectors, the viewer location, and the light location. So the L, V, and N, all these vectors are calculated here in the vertex shader and passed on to the rasterizer, which will interpolate all these values. And the lighting would be calculated in the fragment shader. We also define uniform variables that we receive from the application program, which are the model view matrix, the light position, and the projection matrix. So the matrices are 4x4 matrices, and the light position is just a 4-dimensional vector. This is the main function where we just simply calculate the normal vectors in the same way that we did before. We are not normalizing them here, we're just keeping them as they are. So we multiply the normal vector with the model view matrix, and we only take the x, y, z components of this vector. And just for brevity, we have skipped where we are combining a fourth component of 0.0 with the normal vector here. The viewer is again at a negative v position after multiplying the v position with the model view matrix. So that's because the camera is always at 0, 0. And the position of the light vector is the light position minus the position of the vertices after multiplication with the model view matrix. And we multiply the vertex position with the model view matrix and then with the projection matrix and put them in the GL position inbuilt variable of the vertex shader. So it passes down the pipeline. This is the fragment shader for Phong shading, and this is where we will be calculating per fragment shading. We receive the normal vector, the light vector, and the viewer vector as in variables from the vertex shader, and we also receive the uniform variables from the application program, which are the ambient product, the diffuse product, and the specular product, because these values are required in fragment shader now as opposed to the vertex shader in the previous grad shading example. We also receive the model view matrix because we will need this as well, the position of the light source, and the shininess coefficient. The main program of the fragment shader looks like this. We normalize all the vectors because we did not normalize them previously. And now we call them N, this would be V. We call them N, V, and L. And then we calculate the half wave vector by adding L and V, which is the light source and the viewer location, and then normalizing it back to unit magnitude. And then we define another variable, ambient, and put the ambient product into this variable, because that's our ambient component of the lighting. It's simply is not a function of the position of light sources and normals at all. Next, we calculate the diffuse component by taking dot product of L and N and taking the max with 0. So if this is L dot N is negative, we don't take the negative values, we simply truncate it to 0 because there cannot be negative reflection. So this is basically this part of the lighting calculation, the diffuse part, and then we multiply it with the diffuse light. So we calculate the diffuse component and multiply it with the diffuse light. So this KD is basically here. Next, we calculate the specular part with taking n dot h raised to a power beta over here, and then multiplying this with ks over here. multiplying ks with the specular product of the light over here. So this is the specular product. And then we ensure that we do not give any specular component if the light is behind the vertex or the fragment. So we find out the dot product of L and N, and if it is less than 0, we just simply take 0 for the specular reflection. And once we have calculated all these values, we just simply add them up. So this is the addition. Add the ambient, specular and diffuse components, and we put them in GL flag color. And we set the alpha values of the flag color as 1, and then this gets passed on as pixel values to be rendered.